VLPSos here. This is a video lesson for Python programming, data type dictionary. I recommend pausing and practicing on occasion. I have typed in a review of data type list, some reminders of what a list is and how we use it. I've made a list and I've included Dojun and Catan, two strings, to make a list of length 2. Notice that the list brackets are square parentheses. We can put the type function, we can put the list into the type function and then print it to observe that Python considers it to be a list. We can add to lists with the append function, and then we'll print the contents to see if that's worked. We can iterate through a list, which means that we can go through them with a for loop and print their contents. Lists have a length. We can find the length of a list with the length function, and we can remove things from a list with the remove function. It's often wise to check to see that what you intend on removing from a list is in the list in the first place, because if you remove something that isn't there, it'll cause an error in your program and your program will break. Let's see the output. We can see that the type is considered to be list. We've added to the list, so it's now length 3. Here's the evidence of iterating through it and the print of the length, and then we removed and saw the list after something was removed. Now onto something new. There is another data type similar to list, but with some important and useful differences. The Dict, or dictionary. Dict is short for dictionary. We're going to create one and call it Dict is equal to. I'm going to start the dictionary with the squiggly parentheses. So the parentheses that we use are different than a list. These squiggly parentheses are one of the symbols that show Python that we intend to make a dictionary. We're going to start with contents. I'm going to type 1 colon and then a string. This is a single element in this dictionary. The 1 is being used as what we call the key, and it is associated with the string that we're going to call the value. I'm going to put a second element into this dictionary, and when I do, I'll need a key and a value. In this case, a key 2, and the value is the string Catan. And I can print the type function that is going to return what Python considers to be the type of our Dict variable. When I save and run, I can see my previous code with the list, and we have this new line, class Dict. This is indeed recognized as a different data type. Note the squiggly brackets. There are 2 elements in this dictionary. Each is a combination of key and value. Those words are in capitals because we're going to use them very frequently when we talk about dictionaries and using dictionaries. The keys are 1 and 2. The values are the strings Dojun and Catan. We can add to this dictionary, now that we have one defined, we can modify it. This is how we do that. We refer to the name of the dictionary that has been previously created, and in square brackets, which look like an index, we put a new key. And then we set this equal to the value that will be associated with that key. And we can print our dictionary to see if this new key and value shows up when we run. I'm going to put an empty print line so that there's a space between our list examples and the new ones that we're working on. let's see. Here is the dictionary after we added something to it. The new key and value is there. Note the new key 8 does not need to be in order. We previously used key 1 and key 2. There's no reason that our new key has to be 3. We could use any key we wish, but we would like to use a new one so it doesn't overwrite the value for the key that we previously used. I'll repeat, note the new key 8 does not need to be in order. It doesn't even need to be an integer. Dictionaries are unordered, meaning if the content were arranged differently, it would not matter. For that reason, you cannot index a dictionary. So our dictionary, the way that we've written it, has the keys in order 1, 2, 8. But a dictionary that had the same elements but in a different order would be considered to be the same dictionary. There is no position that we refer to in a dictionary like we do a list. Dictionaries are not indexed. This comment says the values of a dictionary are accessed by reference to the keys rather than an index. For example, we could refer to our dictionary by its name, and then in square brackets, which are similar to an index, we place not the position of something, but the key that we wish to print the value of. 1 is associated with a value in our dictionary, and we can see which one by printing. Here's our dictionary. The key 1 is associated with the string dojun, so when we printed a dict with a key of 1, we got dojun. The keys method, along with list, can make a list of the keys of a dictionary. So keys is a method that works on a dictionary, and list is a function. So we could assign the variable keys and set it equal to a call to the list function, which means we're going to make a list out of what we put inside the list function. And what we're going to put inside is our dictionary with the keys function appended to it. So this line of code is going to take our dictionary, the keys function is going to work on it, and it's going to produce just a set of those keys that are in the dictionary, and then it'll make a list out of them and assign it to the variable keys. We can see what we get when we print keys. And we can see that we have a list, and it just contains those keys that were in the dictionary, 1, 2, and 8. Dictionaries are iterable with 1 T, which means that we can use a for loop and say for key in our dictionary, do something. And what we're going to choose to do is print 2 things. The key and then the value associated with that key. So I print a value in a dictionary by referring to the dictionary and then square brackets, which isn't an index, but we put the key here, and we are iterating with our iterating variable called key. So if we need to put the key into the square brackets of our dictionary in order to access the value with that key, then we're going to get every value in our dictionary because we're going to iterate through the dictionary, and our iterating variable that we called key is going to take on the value of all the keys in our dictionary. Let's see the result. We can see that we had those 2 things printed. the key, and then the value associated with that key in a loop, so it processes all of them. Dictionaries have a length, just like a list. We can use the length function to find the length of the dictionary. So if we print what the length function determines on our dictionary, we can see that our dictionary indeed has a length of 3, not a length of 6. There aren't 3 integers and 3 strings to make a total of 6 things in this dictionary. There are 3 elements in the dictionary, and each element is an association between a key and a value. And finally, we can remove things. And like lists, we want to check, we want to be in the habit of checking with a condition that what we intend on removing exists or is in the dictionary before we attempt to delete it. Because deleting from a dictionary something that doesn't exist in the dictionary will cause an error and break our program. So in this condition, I'm testing whether the key is in the dictionary. Notice that I don't have to know what the value associated with the key 8 is. I can simply refer to the element by its key. So if we have key 8 in our dictionary, we want to delete it. We use the keyword del for delete. We refer to our dictionary, and then with square brackets, we put the key of the thing that we want to delete. And we can check to see if we did by printing the entire dictionary. And we can see here that after we got the length of 3, we deleted something, and now our dictionary has 2 elements in it. 2 key value associations. So why do we have dictionaries? Well, the values of a dictionary can be just about anything. In this example, our dictionary had values that were strings. But things way more sophisticated than strings, like characters, profiles, maps, anything we want our program to work with, dictionaries can be used to manage collections of complex objects that we create, accessible by their keys. Dictionaries are incredibly efficient when we get into working with classes, and collections of what we're going to call objects. Now you have seen how to make a dictionary. In a simple program, make a dictionary that has at least 3 pairs of key value. Make your keys be strings instead of the integers that we saw in this program's example. Make your keys be strings, the names of some family or friends. Make your values be a simple message about them, like great at badminton. Then iterate through your dictionary, printing both keys and values like the example above. Then add and name a message to the dictionary. In other words, add another key and value to the dictionary, not by rewriting the dictionary, but by using the convention of adding to the dictionaries as you saw. And remove an old one, just like the example code removes from a dictionary. Print the content of the dictionary as you did before to show the changes.